Today we're going to review for your Chapter 3 test. So this is over everything that we've done in Chapter 3. So topic 1 was over relations and functions. Our first directions say to identify the domain and range of each relation, then determine whether the relation is a function. So the first thing we have to remember is that the domain are the x values. This is our input, and the range are our y values, our y coordinate. We refer to that as our output. So on question number 1, they give us a set of ordered pairs. It says -6, 4, 5, -1, 0, 3, and -2, 4. So remember, in a set of coordinates, it goes x and then y. And remember that the x coordinates, our x values, are the domain. So our x coordinates would be -6, 5, 0, and -2. The other thing we have to remember when we write domain, we have to write it in order from least to greatest. So our smallest number is -6, then -2, then 0, and then 5. Similarly, our range is our y values. So the y values come second. So 4, -1, 3, and 4. And we too have to write this in order from least to greatest. So our smallest number is -1, then 3, and then we have 2 4s. And remember, we don't have to write repeats. You only have to write 1 4. So our range would just be -1, 3, and 4. To determine if something is a function or not, remember we look at the x value and make sure that everything is different. If all of the x values are different and none of them repeat, we would say it was a function. If any of them repeat and go to a different y value, then it would not be a function. So in this case, we have -6, 5, 0, and -2. None of them repeat, so we would say yes, this is a function. So that's how you would do it with ordered pairs. You would do the same thing using a table. It just looks a little bit different. So again, our domain are the x coordinates. So this time it's just written in a table. So for our domain, we would list those x coordinates in order from least to greatest. So first it would be -4, then it would be -3. Notice there's 2 -3s, and we don't write the repeat. And lastly, it would be 0. For our range, it's going to be our y coordinates. And again, we write them in order from least to greatest. So our smallest range is -5. Then we have 1. Then we have 2. And lastly, we have 8. To determine if this one is a function or not, again, remember to check out the x coordinates. If any of them repeat and they go to different y values, it is not a function. So notice we have -3 going to 1, but we also have -3 going to 2. Because -3 goes to different y values, this one is not a function. All right, the last representation, or second to last representation, is graphically. So we have to think ordered pairs when we do the domain and range here. It may even be beneficial for you to go through and label all your dots on your graph. So I'm going to go ahead and do that first. So our first dot over here is left 1, 2, 3, 4, 5. So left 5 and up 1, 2, 3. So that's at -5, 3. This dot, it's not left or right any, it's just up 1. So that would be 0, 1. This dot over here is right 1, 2, 3, 4, 5, and up 2. So right 5 and up 2. Our dot down here is at 1, 2, 3, left 3, down 3. So left 3 is -3, and down 3 is -3. And our last dot on our graph is right 2 and down 3. Right 2 is positive, down 3 is -3. So now we have a bunch of coordinates, and we can kind of do this similar to the first one we did. So remember, domain is our x coordinates. So let's find all our x coordinates. X come first. Now that we've identified them, we're going to write them in order from least to greatest. All right, so our first one's going to be -5. Our second one's going to be -3. Then we'll have 0, then 2, and last we'll have 5. So that's our domain. Our range are the y values. So we have 3, 1, 2, -3, -3. So if we write these in order from least to greatest, -3 is our smallest. It is repeated, but we only write it once. So that takes care of these two. Then our next one would be +1. Then we have +2. And lastly, we have +3. So to determine if this is a function or not, we could either use the vertical line test, or we could just look to see if all of our x's were different or not. And in this case, we had -5, 0, 5, -3, and +2. They were all different, so you would say, yes, this is a function. Now I would like you to try number 4 on your own. So you're going to do this one similar to number 3. For number 5, we're going to use the mapping to determine the domain and range. So remember, in our first oval here, those are our x coordinates. And the x coordinates are the domain. We just have to remember to write it in order from least to greatest. So it's already written in order from least to greatest, which is nice. So we have 0, 4, and 9. Then our range are the y values. So we'll copy those down. Our range is 2, 3, 4, and 5. Notice, to determine if something's a function or not, we have to think, does the x repeat? So if 0, it says 0 goes to 2, 4 goes, so that's like writing 0, 2. Maybe we'll do that. 4 goes to 3, 9 goes to 4, but 9 also goes to 5. So you can see this 9 repeats. Whenever an x value repeats, it is not a function. An easy way to determine that on a mapping like this is when you see that double arrow, it most likely means that it's not a function, because that one x value is going to 2 different y values. Now I would like you to try number 6 on your own. For number 7, 8, and 9, we're going to use the graphs to determine the domain and the range. So remember, the domain are the x values, and we think about this on a graph, it would be how far left and how far right does our graph go. Well, notice we have these arrows here. That's going to continue going forever and ever to the left, and this arrow over here will go forever and ever to the right. So when something goes on forever to the left or to the right, or even up and down, we have to use infinity. So when something's going forever to the left, we say -infinity. When something's going to the right, we use positive infinity. And we always use parentheses with infinity. Our range is how far our graph goes from top to bottom. So on the bottom, these arrows will continue to also go down. But at the top, our graph stops right here. So we need to figure out where that's at. So we said it's going to go forever down, so that would be -infinity. But it's going to stop at 1, 2, 3, 4. It'll never go past 4. So we write 4 and we use a bracket because this is a dot on our graph. So it's like a closed circle there. So we use a bracket. Then to determine if this is a function or not, we can use the vertical line test. So pick anywhere to draw a vertical line straight down and figure out how many times that vertical line hits your graph. You can pick anywhere. I'm picking lots of them. But if you notice, no matter where I pick, it only hits the graph once, right? Our vertical line only hits graph one time. When it does that, you say, yes, it is a function. If your vertical line test hits your graph more than once, you would say it is not a function. But this one only hits it once. So we would say it is a function. All right, I'm gonna have you go ahead and try number 8 and 9 on your own. All right, for 10, 11, and 12, these are all real world situations where we have to pick which graph best represents the situation. So I'm gonna go ahead and do number 10 with you. Number 10 says, Karina is riding a horse on a carousel. Which graph best represents her distance from the center of the ride in a single rotation? So think about when you're on a carousel. You have the center of the ride, and say you're on the horse that's out here. Think about when you go around. It's a circle. So are you going to get any further away from that center? Or are you going to remain the same distance? You should remain the same distance, right? It's just going to go in that circle, and any point on a circle is the same distance away from the center. So because our distance from the center isn't changing, you would say graph B. Throughout that whole ride, I'm going to remain a constant or the same distance from the center. All right, go ahead and try number 11 and 12 on your own. For number 13, it says to complete the table and then graph the function. So we have y equals negative 2x plus 5. So you can use your calculator and input your equation and use the table function there. I'm also going to solve these algebraically for you just as a reminder of how to do that. So these are our x values. So where x is, we're going to replace that with whatever our x value is. So our first one, we would do y equals negative 2 times 0 plus 5. Well, negative 2 times 0 is 0, and 0 plus 5 is 5. So we would have a point at 0, 5, which means don't go left or right any, just go up 1, 2, 3, 4, 5. So we'd have a dot there. All right, our next one, we're going to plug 1 in for x. So it would look like y equals negative 2 times 1 plus 5. So negative 2 times 1 is negative 2 plus 5. Negative 2 plus 5 is 3. So we'd have a coordinate at 1, 3. That means to go right 1 and up 3 and put a dot. All right, our next one wants us to input 3 in for x. So y equals negative 2 times 3 plus 5. So negative 2 times 3 is negative 6, plus 5 is negative 1. So we have a point at 3, negative 1. So it'd mean to go right 3 and down 1. Our last point would be to plug 5 in where x is. So y equals negative 2 times 5 plus 5. Negative 2 times 5 is negative 10. Negative 10 plus 5 is negative 5. So our last point is going to be right 5, down 5, and it would look like that. So this is what our function would look like graphed. Go ahead and try number 14 on your own. On number 15, it says to find the range of the function y equals 3/4 x plus 17 when the domain is negative 12, negative 4, and 8. So they essentially gave us here all of our x values or our x coordinates. So we could make a little table over here, and these become just like the last ones where I know I need to input negative 12, negative 4, and 8. So when I say input, I mean to put it in for that x right there. So we're going to do 3/4 times negative 12 plus 17. So I first put in this negative 12. When you put that in a calculator, you should get 8. The next one I'm going to put in is negative 4. So you'll do 3/4 times negative 4 plus 17. And your output or your y value should be 14. Your last one would be to input 8. So we're going to do 3/4 times 8 plus 17, and you get 23. So we essentially just found our range. So the answer to our question would be that our range are those y values I just listed. So 8, 14, and 23. All right, for topic 4, it says for questions 17 through 22, find the function values using the given function below. And they tell us that f of x is equal to 5x minus 20, g of x is x squared plus 5x minus 11, and h of x is the absolute value of 2x plus 7. So I'm going to go ahead and do number 17 with you. It wants me to find f of 6, which means I have to use the f function. And I'm going to plug 6 in for x. So f of 6 would be equal to 5 times 6 minus 20. So 30 minus 20 means that f of 6 is 10. I'd like you to try 18 and 19 on your own. For number 20, it says to do g of 7 minus 15. So I'm going to use this g function here. And where there is an x, I'm going to plug 7. So I have to do 7 squared plus 5 times 7 minus 11. Notice I plugged it into both x spots. I also can't forget to subtract my 15 at the end. So 7 squared is 49. Plus 5 times 7 is 35, minus 11, minus 15. When you put that in a calculator, you should get 58. Now I would like you to try number 22 on your own. For number 23, it says given f of x equals 5 minus 3x, if f of x equals negative 19, find x. So we're going to do the opposite here. I tell you what f of x is, and we're finding x. So we were given this part, and we're going to have to solve it for this, the x, what I highlighted in blue. So I'm going to first substitute, I know f of x is negative 19. So I'm going to rewrite this. Negative 19 equals 5 minus 3x. Then I'm going to solve this for x. So my first step would be to subtract 5. I'd get negative 24 equals negative 3x. Divide by negative 3. And you get x equals 8. All right, now I'd like you to try number 24 on your own, and you're going to be doing the same kind of thing. For number 25, it says to find f of negative 6. So that means, remember, this is your x value, right? Because when we write these, it's like f of x. So that's when x is negative 6. It's asking you, what does y equal? So at negative 6, 1, negative 2, negative 3, negative 4, negative 5, negative 6, my y value is here, right? This is where my x is negative 6. That y value is 1, 2, 3, 4, 5, 6, 7. So this is 7 right here. So your y value is 7. So you would say equals 7. So you're going to do 26 the exact same way. 27 is the opposite. This time I'm saying, hey, y equals negative 5. When y is negative 5, what is x? So we're going to find negative 5. 1, 2, 3, 4. So here's when y is negative 5. You have to look what x coordinate is there. Well, that's right 2. So what is x? X equals 2 when y is negative 5. So go ahead and try number 28 on your own. For number 29, 30, and 31, you're going to identify the zeros of the function. For this, just remember that a 0 is when your x value is 0. Graphically, it's where your graph crosses the x-axis. So on this one, if we count 1, -2, -3, -4, our graph crosses the x-axis at -5. So our 0 of this function is when x equals -5. And I just realized I said that wrong. It's when our y value is 0 up here. It's where your graph crosses the x-axis. So graphically, you're just going to look, where do these things cross the x-axis? And you can have 1, 2, 3. You can have many zeros of a function. So go ahead and find the zeros of number 30 and 31. For 32 and 33, it wants us to find the zeros of each function algebraically. So like I said up there, to find it algebraically, it's going to be when y equals 0. So we're going to substitute or replace 0 for y. So where f of x is, remember that's just the same thing as y. So I'm going to substitute 0 in for y. And I have 0 equals 8x minus 16. Solve that for x. So add 16 to both sides. You get 16 equals 8x. Okay, go ahead and do this over here. Divide by 8. And you get x equals 2. So there is a 0 at x equals 2. Go ahead and try number 33 on your own. For number 34, you're going to do the same thing, putting these into your calculator. So it's going to be like 29 through 31. Put them in your calculator and find the 0 of each function graphically using your calculator. So in y1 on your calculator, you're going to type -x squared minus 7x minus 10. When you hit graph, make sure your window is right so that you can see your graph. So I'm going to have to move mine over a little bit. And when I can zoom it in to see it, you can see that it crosses the x-axis, -5 and -2. So the zeros for number 34 are x equals -5 and x equals -2. So x equals -5 and -2. All right, that concludes your video for the review for your Unit 3 test. If you have any questions, let us know.